Hi, I'm Cosimo Pecchioli and I'm with Alfa Laval Data Centers Cooling Solutions, and today we talk about filters for plate and frame heat exchangers. There are essentially three main categories of filters. There are large filters that you use to screen a large amount of water that you pull out of like rivers, lakes or the sea for your facility. Then there are strainers, and then there are port filters. Large filters like the ALF filters from Alfa Laval, and I'm posting a link below, are designed as I said at the beginning, to accommodate a very large amount of water and a very large amount of solids. Normally they are self-cleaning and they need very little maintenance, but they are big, bulky, and normally fairly expensive. The most common solution used for a cooling system are strainers. And strainers are, of course, a good solution. The only challenge, well, maybe not the only, but the main challenge that we see speaking about plate and frame heat exchangers and strainers is that in order to design the right mesh, you need to know the size of the channels inside of your heat exchanger. And that leads us to the concept of the pressing depth. We talked about the pressing depth in previous videos, but let's recap what we talked about. Here you can see three examples of different pressing depths, and you can see that the size of the channel, of course, is different. Why is that important? Well, let's say in this picture, these are the plates, and of course, you need to know what is the size of this channel in order to design a filter that is different from a filter that, for instance, for this channel. And let's assume, for instance, that in this case, this channel is 2.5 millimeters. We normally recommend that you don't have particles that exceed 75% of the size of the channels, which equals to 1.8 and change millimeter. So once that you know that you cannot have particles bigger than 1.8 millimeters going through your heat exchangers if you don't want to build them up, you of course design your mesh accordingly. And the same goes for here. Let's say that in this case, for instance, this is a 1.5 millimeter. You need to design your mesh in the strainer for particles that are around 1 millimeter. Unfortunately, as provider of heat exchangers, we are not asked very often what is the size of the channels, and therefore we see in strainers filters with meshes that are like 4 millimeters. And you understand that in that case, of course, you screen out the washers, the bolts and the nuts, the gloves, all these very large debris, but the finer particles, you end up building them up in the heat exchanger. And you have to imagine that on top of that, if you have fluffy or soft particles like paper bags or plastic sheets, they actually are pushed through the holes of the strainer, and they end up in the heat exchanger in the contact point of the plates. And the third solution, of course, is the port filter. The port filter comes with the heat exchanger, so it's provided by the vendor, so you don't have to worry about matching the mesh with the size of your channels, because that is done by the vendor. And it has another advantage that is inside of the heat exchanger, because another concept that is important is that, of course, you position your strainer as close as possible to the heat exchanger so you don't have any contaminants after the strainer. In this case, in case of the port filter, and here you can see a picture of a port filter, you see that the port filter actually is kind of embedded inside of the heat exchanger. In theory, you can have, of course, port filters in the 4 ports, but it doesn't really make sense. You want port filters normally only in the inlet of the cold water coming from the cooling tower, or from the chiller, in any case, the cold inlet. As you can see, you pull the port filter out from the inspection port on the back, so as a strainer you don't have to disconnect the heat exchanger. Of course, as the strainer, you have to stop the flow and close the valves. But other than that, it's a minor disruption of your operations. So it's always a good idea. They are not mutually exclusive. It could be a good idea to have a larger mesh in a strainer before the heat exchanger, and then you can have actually a port filter in the heat exchanger. The pressure drop that you have adding a port filter is negligible, so we always suggest, if you have a chance, to include the heat exchanger in your initial design. You can retrofit an existing heat exchanger with a port filter, but in that case you have to disconnect the heat exchanger to accommodate like a cone section that drives the filter back when you push it back into position. So it's of course an operation that you have to do only once, but you have to disconnect the heat exchanger to install the port filter if it doesn't come with a port filter from the vendor. That's it, essentially. Important to remember, actually, to close this video, is that about 90% of the large debris that you have in your heat exchanger, they come at the startup. When you have a new system and you have all the contaminants and all the washers, paper clips, pans, whatever, hats that you have in the piping, particularly if you have fairly large piping, it's not uncommon, and they end up in your heat exchanger. So definitely pay attention at startup. It's one of the most important, the critical time and the most important thing that you pay attention. You don't want to start up a new system and then having to open the heat exchanger immediately because it's completely fouled. With this kind of filters, of course, you screen out fairly large particles. They are not particularly helpful for another kind of fouling, which is very fine particles, dust, sand, seeds from the cooling tower, and or scaling from the water, the quality of the water. At that point, actually, the shear stress inside of the heat exchanger is more important, but we have discussed this concept at length in previous videos, so we will not talk about that particularly in this video. If you have liked this video, please like it, subscribe, and as usual, if you have any questions or comments, leave them below and we will answer them. Thank you for watching and have a great day.